All right, we got Unit 3, Lesson 12, Practice of Proportional Relationships. All right, so what do they mean by proportional? Well, in this scale drawing for exercise 12.1, Vegetable Garden, they have a scale, okay? And the scale says for 1 unit, okay, it's going to be 2.8 feet in the real world, all right? So you have AC, which is 3. Well, how much is that in feet? Okay, so that's where we would use the proportionality or for that scale. So 3 units, right, is how much in feet. So let's figure that out. In fact, I'm going to write a proportionality statement to solve for that. So we're looking for AC, right, in feet, right? We know that it is 3. Meanwhile, we know that 1 unit is 2.8 feet. I'm going to go ahead and cross multiply. All right, if I do that, I get 1 times AC, and then I get 3 times 2.8. Okay, so I'm already cross multiplying. And what do you get in your calculator if you were to multiply 3 times 2.8? You should get 8.4. 8.4 what? 8.4 feet. So again, this right here is a proportionality statement that allows me to set up to solve for any missing piece. Okay. All right. So what about any other ratios? Try doing BC. So like what is BC? So set up a proportionality statement for BC and let me know what you get. Okay, so hopefully you pause the video and you tried out BC. All right, so BC is what in feet? We don't know. We do know it's 5 units, and that is in relation to the scale, which means 1 unit is 2.8 feet. So notice how the top, right, the numerators are the feet, and the bottom are the units, right, of our proportionality statements. All right, so if you cross multiplied, you should have gotten 5 times 2.8 feet. And what do you get? Should get 14 feet. Yeah. Okay. All right. So the one that I'm not going to do for you that you have to do on your own is I want you to find the feet or the length for AB in feet. Okay. So set up your proportionality statement. Okay. And then solve for AB. That's something that you have to do. Okay. Let's move on. All right, card sort corresponding parts. So again, when we talk about similarity, we're also looking at corresponding parts to see if they have a scale factor in common or they have certain angles in common. We know that all you need is angle, right, to prove that two triangles are similar. So if we look at these card sorts, all right, they definitely want a similarity statement, a scale factor, and the missing length solved. So right away, from these 4 cards that you guys see here, which two triangles would be similar to one another? So hopefully you paused the video and you found the 2 triangles that would correspond or that would be similar to each other. I noticed the angles here of card or triangle A and triangle C are congruent, right? So I know, okay, that triangle, let's see, ABC is similar to triangle, let's see, where am I? Let's see, making sure I get this right. Triangle HGJ. There we go. So I'm making sure they're corresponding. Okay. All right, so I noticed that these two triangles are similar, but what about the scale factor, right? They want a scale factor. So one, the similarity statement, two, the scale factor. I notice between these two triangles that BC, right, becomes bigger when it becomes GJ. So 4 times what scale factor gives me 6? I can reduce. There's 3 2's and 6, 2 2's and 4. So that is the second part, your scale factor. Okay. Now, if they were going the other way, right? Like if they went this way, big to small, then it'd be the other way, 2/3. Right? So if they were getting smaller, they'd be multiplying by a scale factor of 2/3. So just be aware of that. Okay, missing sides, right? I'm missing HJ. So let's see. HJ is to AC, right? So HJ, and this is number 3, by the way, the missing sides. HJ is to AC, as is. Let's get some more sides to go off of. Let's use blue. BC, or I'm sorry, GJ is to BC. Okay. So GJ is to BC. All right. Now that proportionality statement is going to help me find that missing length of HJ. Okay. So basically, HJ is we don't know. AC, though, we know is 3. JG is 6. And BC is 4. Now, the reason I picked GJ and BC was because both of their values were known, which would totally help me solve for HJ. All right, cross multiply. Okay, so now we're solving for HJ. 3 times that 6, right? So we got 4HJ equaling 18. Let's see, division. Divide both sides by 4. Both are, yeah, both have a factor of 2, GCF of 2. So there's, let's see, 18 divided by 2 is 9. 4 divided by 2 is 2. So HJ is 9/2 or 4.5. Okay. I notice I'm missing AB, right? So I'll tell you what, for you guys, for you kiddos, solve for AB. All right. AB is to who? HG. Let me use lime green here. AB is what we're solving for, is to HG. Okay. And what's funny is we could still use BC is to GJ. Okay. Go ahead and solve for AB. All right. Go ahead and solve for AB. That's for you. All right. Very similar to this, just different sides, of course. Okay. All right. Let's see. So for you, which two, all right, so of these 3 cards, right? Card D, E, and F, which 2 triangles are similar to one another? Okay. So write the similarity statement and then find, let's see, what is it? Find the scale factor. All right. And then also find the missing sides of those two triangles. Okay? All right. So hopefully you guys did that. In summary, we have proportionality statements. So whenever you have two triangles that are similar, okay, they have the same ratios, all right, because they undergo the same scale factor, right? So there is a proportionality between corresponding sides. For example, AB, okay, is to BC as is DE is to EF. Do you see the pattern there? Okay, that could be a proportionality statement. Let's look at another proportionality statement. AB is to AC, so the short leg to the hypotenuse, is to DE, which is the short leg, to, again, the hypotenuse. So notice the proportionality statements. You're comparing corresponding sides of two triangles that have to, that are similar. Okay, let's look at the next one. Let's see what they're comparing. AC is to BC. So AC is to BC, so hypotenuse to the base, is to DF, the hypotenuse, to EF, so hypotenuse to the base. Okay, so you're comparing oranges to oranges and apples to apples. Okay, basically that's the idea of proportionality statements. Now, when you have proportionality statements, you can solve for those missing pieces. Okay, for example, for DF, okay, let's say I want to solve for DF. Like I just want to know what DF is. DF is to, let's see, AC, right? Hypotenuse to hypotenuse. As is, let's see, EF is to BC, so the bases. There we go. So DF, we don't know what it is. AC, we do know is 5. EF, we know is 6, and BC is 4. Cross multiply can help solve for that missing piece, that missing side that we are looking for. Okay, division. Let's see, we can totally reduce. Let's see, by 2. All right. And that should give us 7.5 for DF. Okay, so that's an example. And you can also give, looks like for their example here, ooh, battery, low. Okay, good to know. All right, DE, as you can see, they're solving for DE. You can use several proportionality statements to get you DE. Personally, whenever I look to solve for a length, I like to put whatever I'm solving for in the top left. Okay, so for example, if I was to solve for DE, like in their example, DE is to AB, right? DE is to AB. As is, let's see, what do we have? EF is to BC. Now notice my proportionality statement is a little different compared to the other two that they give us. The reason I put mine the way I put mine is because DE is in the top left, so that when I just cross multiply, I already get DE off to the left-hand side, just like how DF stays on the left side all the way down. So that's just one of the reasons I do my proportionality statements in such a way. Okay. All right. Have a beautiful day, and we'll get more practice.